Hi everyone, welcome to my channel. Today we will discuss why most of Spring Boot application fails in production. As we all know, Spring Boot is amazing for building apps quickly, but production is a different world. After working on multiple production systems, I have noticed some mistakes that we do again and again. So today we will discuss how we can avoid these mistakes. So let's start with one of the most common reason, thread pool mismanagement. By default, Spring Boot provides annotation at the async executor with a thread pool. At first glance, this looks great. You can process tasks asynchronously without blocking the main thread. Let me open a diagram to showcase how it will work. So if a thread is available, it will process the request and send back the response. But here's the catch. If too many requests come in and some threads get blocked, for example, waiting for a slow database call or calling another microservice, new requests have to wait in a queue. This queue is often unbounded, meaning it can grow very large, consuming memory and causing application to slow down. Eventually, the thread pool gets exhausted. Requests start giving timeout and your systems become unresponsive. So what's the solution? Always configure your thread pool size according to the expected load. Monitor thread usage in production by using tools like Micrometer or Spring Boot Actuator that can help. Avoid blocking operations inside async threads wherever possible. So if an operation is blocked operation, like it can take time, so avoid using async blocks. How we can configure uh, thread pool size? So we can create thread pool task executor object. We can set the pool size. We can set maximum pool size. Set the queue capacity, and also we can give the name to that asynchronous thread. So maximum pool size will set 50. It will take care like thread will not increase more than 50. And we can use this executor in the service class by just using the bean name of task executor inside the async annotation. And that will automatically control the maximum number of threads that can be used inside the payment service. The next big culprit is database connection pool exhaustion. Uh, Let me open a diagram to explain. So Spring Boot uses Hikari CP as the default connection pool, which is fast and lightweight. However, many developers leave the default pool size unchanged. This default is usually too small to handle the real production traffic, especially during peak load. Imagine your application receives hundreds of requests at once. Each request requires a database connection. So if all the connections are in use, new requests have to wait. If the wait is too long, they time out. This is why sometimes your API hang or fail randomly and it look like the system is unstable. So long running queries, inefficient transactions or connection leak can make this situation even worse. If you don't monitor the pool usage, these problems may go unnoticed until user report failure. So how we can solve this problem? We can configure Hikari CP properly for your expected load, set few properties like minimum idle, maximum pool size, and connection timeout based on traffic. Monitor connections using Spring Boot Actuator or tools like Micrometer or Prometheus. Optimize queries, avoid long running queries or blocking queries, and make sure connections are always released back to the pool. So, here is the code which explains how we can configure the Hikari. We can set JDBC user URL, username, password, minimum idle connections, maximum pool size, connection timeout. If long running query is taking more than 30 seconds, we need to stop the queries, idle timeout, and max lifetime. So these are the major two problems that can help to avoid Spring Boot application failures on the production.